IRS wait time. The Internal Revenue Service claims that the average wait time for callers during a tax filing season was at most 10 minutes. A random sample of 8 callers has an average wait time of 12 minutes with standard deviation 2 minutes, alpha equals to 10%. We want to reject this claim. So they claim at most 10 minutes. So mu naught is equals to 10 minutes. And then we have a random sample of 8 callers and the average wait time is 12. So x bar is equals to 12. The sample standard deviation is equals to 2. And then alpha is equals to 10%. So since we have an unknown population standard deviation, then this problem follows the T procedure. And then the next step is we have to state the H naught and HA. So the H naught is the first sentence, at most 10. So mu is at most, so that is less than or equal to 10. And then HA is the opposite, right? The problem didn't give me a sign for HA, so I will take the opposite, greater than 10. So that is for H naught and HA. And then the next thing is I can go ahead and calculate the test statistic. So the test statistic, the T, is equals to x bar minus mu divided by sample standard deviation over square root of n. And then we have p-value. Okay, let's calculate this. So we go to stat, and then we from edit, we just see edit first, and then you go to test, and then you do the t-test. And then since there is no data, we select the stats option. Mu naught is equals to 10, so we write 10. And then x bar is equals to 12. And then sample standard deviation is 2. The sample size is 8. And then what's the symbol for HA? That is a greater than. So this symbol determines the p-value. Greater than means is a right-sided test. So this is a right-sided test. All right. So let's hit calculate. So hit calculate, you have 2.82. So T is equals to 2.828. I would like to keep 3 decimal places, 2.828. And then the p-value is 0.0127. 0.0127. That is less than alpha. So this is a reject H naught. And then if you press draw, what do you see? If you press draw, they will give you a graphical representation of the test statistic and the p-value. So that is what you are going expect to see when you press draw. So you get a bell curve, and then you have 0 right in the middle. So that is t equals to 0, and then 2.828 is 4 on the right. So this is 2.828, and then the p-value is 0.0121. So this p-value is 0.0121. That's the p-value. One thing that you don't see on the graph is there is no rejection region. So let me add to the graph. So this is a right-sided test according to the greater than. So this is a right-sided test. That means the rejection region is on the right-hand side. And then the 10% is greater than the purple region. So 10% is like right here from this cut all the way to the right. So we know that the rejection region is greater than the purple regions, and then the purple region is inside the rejection region. So that's why you reject the null hypothesis. Again, the purple region, the p-value is inside the rejection region, which means p-value is less than alpha. That's why you reject the null hypothesis. What if your teacher asks you to use to compare the test statistic to decide reject or fail to reject? Then this one you will have to use inverse T. So you will have to use inverse T. The problem is TI-83 does not have inverse T. So there is a red T right here. So this red T is equals to inverse T. You have to input the area 10% and then degree of freedom 8 minus 1. So let me see what that equals to. 10%, and then the degree of freedom is equals to 7. So that is around past 1.415. So that is 1.415. And then this is greater than this is less than your test statistics. And then since your test statistic is inside the rejection region, then you reject the null hypothesis. So back to the business, we have to reject H naught. So we reject H naught, then HA is true. Now, explain this in a way that everybody understand. What is HA is true? HA is true means the wait time is more than 10 minutes. The wait time is more than 10 minutes. So this sentence, everybody understand. You don't need to take a math class to understand this. The wait time is more than 10 minutes. All right, so we got the answer. Do we have sufficient evidence to reject? The answer is yes, we do, because p-value is less than alpha, so we have sufficient evidence to reject H naught, and then HA is true. So the claim is wrong. They lied to you. They said at most 10. They are lying. The truth is you have to wait more than 10 minutes. It's not at most. Okay, the next part, that is confidence interval, right? So let's do confidence interval. So let's divide this up. I would like to do confidence interval. So what is alpha? Alpha is 10%, so we have 10% alpha, then my confidence interval is 90% confidence interval. The formula is test statistic plus or minus, or not test statistics, alpha, this is point estimate plus or minus t half alpha, and then degree of freedom s divided by square root of n. We have to mention the degree of freedom because the shape of the t distribution, the curve, the t curve, is determined by the degree of freedom. So that's why we need to mention it. All right, let's calculate the CI, confidence interval. So we go to stat. We go to stat, and then we go to test. We do a t interval. So t interval is line 8, and then we have to select the stats option, and then x bar is 12, sample standard deviation 2, sample size 8, and then the last one is 90%, 0.90, and then you calculate. What do you see when you calculate? So you have, let's round this a little bit. So in your calculator, you have 10.66 and 13.34. What is this? This is minutes and minutes. So what is the truth? How many minutes do you have to wait? That number is between 1066 and 13.34. Okay, so let's explain these two numbers. So explain the confidence interval VR, 90% confident. So 90%, that looks like 900. So 90% confident that the true wait time is between 10.66 and 13.34 minutes. Simply speaking, we don't know this. We are trying to estimate the true mean mu. The confidence interval says the truth, the mu, is between those two numbers. Is that means we know what the mu is? We will never be able to find out. I know that the mu is between those two numbers. And then how do you do a verification? I want to support my conclusion. I reject H naught, right? I want to make sure this is right. So all you have to do is you recall H naught. So H naught is mu less than or equal to 10. So this inequality is completely outside the confidence interval. So that is outside the confidence interval. So that is not the truth then. So H naught is not true. Then you reject H naught. I just support myself, reject H naught. Okay, so that is the end of the confidence interval analysis. So I want to ask one more question. That question is, what is the p-value means for this problem? Again, explain what the p-value means for this problem. What is p-value really means? What is the definition of p-value? The p-value says you have a population, and then you took a sample from the population. In this problem, you took a sample. So the first sample you took a sample size is A, and then the average is 12. according to the definition of p-value, I can take another random sample, n2, that is equals to 8, and then my x2 bar will be more extreme than the 12. What do you mean by more extreme? What is extreme? Can you give me a description of extreme? The description is based on the alternative hypothesis. So your alternative hypothesis is HA, right? Is HA is based on this. HA mu is greater than 10. How extreme is x2 bar? That is based on HA. So let me give you a complete sentence for the meaning of p-value. So if H naught is true, you have to start with this. If H naught is true, there is a chance equal to the p-value. (0.0127), that the average wait time is, you use a greater than, so it's greater than, but I want you to add one more to it, greater than or equal to what number? 10? No, not 10. The answer is 12. What is 12? This is my x bar. Again, I am trying to say that when I take the next sample size out and then find out what x2 is, x2 bar, the x2 bar will be more extreme than the x1 bar. Can you describe what do you mean by more extreme? The answer is greater than. You take the greater than from HA and then you include the equal as well. Why? Why do you include the equal? There is no equal in HA because you assume H naught is true. That's why you have to add the equal to it. So based on HA, you also grab the equal as well and then compare that to what? Compare to the x1 bar, so which is 12. So that's what the p-value means for this problem. Okay, before we end this video, let's take a look at a couple screenshots. So the first one is for the test. So you go to stat test and then you see a t-test, right? So stat test, you see a t-test, and then you have to make sure when you input the info, you have to make sure that you select the right inequality symbol for HA. And then there are two options. Either you calculate the p-value and the test statistics, or you draw. So the picture, you have either the calculation or the picture. And then for the confidence interval, you go to stat test as well. You select t interval, and then since alpha is 10%, then the confidence level is 90%. They must add up to 100%, and then you have your confidence interval. In case you are asked to sketch a picture for the confidence interval, here is the picture. So you have 90%, right? So you have 90% area right in the middle. So this is a 5%. This is a 5%. So what is the lower cutoff? The lower cutoff is 10.66. The lower upper cutoff is 13.34. And then in the middle, we have x bar. X bar is equals to 12. And then this is the area of the 90%, in case you are asked to sketch a picture. All right, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me. Appreciate for your help. See you all in the next one. Signing off for now.